Now, the two arguably most important concepts. One is the union. So, this is going to be a little wordy, but we'll make sense of it with examples. The union of set E, some general set, with set F, how much time we have? Is the new set, and it's going to be named E, then with a little cup symbol, and then F. It's the new set that contains, let's go with any or every element that is in E or in F or in both. I know it's wordy, there's no way around it. So let's take our time, understand those words, and then by way of examples, see how it feels. A lot of words to write down. Make sure you write it down correctly. Don't swap out a word for another word right now. Essentially, I'm just saying to combine them, yes. But combining is a slightly vague term. So, let us look at some examples using our 4 in our running example. If I say the union of A and C, let's write it down first. Union of A with, with C. I'm building a new set. See it as building a new set. Anything that is in set A or in set C or in both should be in this new set. So I look at set A, B, C. Little a, little b, little c. Set C also has the little letter C. That's not a new letter. This little c and this little c is the same letter. There's one Scrabble tile that has a C on it. So I'm not going to write C twice. I will, however, write D and E. And of course, there's no arrangement here. They could have been shuffled. It's the collection of things that is important. So literally what I've done is I throw A and C together and see what I have. Just pool them all together. There is no discrimination. If you're in one set, you're in another set, you are welcome to this new union set. How does that feel? All right. But we have other sets, so let's do more examples. What is A union B? If I can click on it, there it is. A union B. Think of intuitively what we're doing. We're throwing all the elements in question between those two, we're throwing them together. There is no double B or double C. It so happens that set B doesn't bring any new letters to the party. Set A already has them all. So by throwing them together, I'm still just left with little A, B, and C. There are no new sets, new letters rather. Let's do the other ones here. Let's say, I don't know, which one do you like? D and A. Sure. D union A. In this case, they don't have anything in common. So I pull them all together, doesn't matter which ones you start with. It's A, B, C, X, Y, Z, all thrown together. You can write them in a different order, of course. Doesn't change the collection of things. So this says over here, if I do the union of a set with something that is just a subset, my set doesn't change. That second set, if it doesn't bring any new things to the party, then I just have what I have. Nothing's changed. So if I take set A and the union with the empty set, who's coming to the party? The empty set is nothing. There's nothing. It's just the same thing. But if I do the union of A with the universal set, who's coming to the party now? Everyone is coming to the party. So I like to think of this party scenario where I'm not discriminating. Everyone's coming. You show up to the door. If you're in one of those sets, I'm opening the door. You're going in. Doesn't matter. Any questions on the union? Yes.
So the first one, A, U, C.
It's a union.
What do we call
A
the
union.
subset now?
What's subset?
The AU. So can you now union that one with a different one after?
I can keep mixing them, yes.
So what would you represent that as if you were gonna like?
Oh, you want, for example, it's not limited to two sets. I can do A union C union D and get a new set.
Okay.
Just more things are showing up at the door. So it's A, B, C, D, E, X, Y. I'm just pooling them all together. So it's not the same concept as a subset, though those two can be combined, like that second line. But it's still a matter of everything gets combined, everything that there is. And I can do it with more than just two, of course. All right. No, that's it. Any other thoughts on union? So, like he said, he called that U. You can think of it as a U to make it easier. Looks like a U for union. If it helps you to remember the correct symbol, go for it. But it's not a U. It's the union symbol. It's a little complicated. But if you write the U there, I'm just going to look the other way and accept it. Make a new page here, because there is one more that is in contrast to this one. There are other ways to combine sets. Because it's not just as simple as numbers, there's only so many ways to combine numbers. Because these things have little objects in them, combining them can be done in different ways. The second way is the intersection. So even though the word sort of gives it away, I'll write the whole wordy explanation. The intersection of set E, some general set, and set F is the new set, and it's going to be named E with an upside down cup, F, that contains all elements in both E and F, and nothing else. The words are pretty much going to stop very soon. It's not going to continue like this. We just get all the concepts done first, and then our typical kind of problem, and that'll be that. It's better to just get all the concepts and the words out of the way. Any questions on any of those words first? Anyone still writing? And it's also in the book, right? So, example time. Whoa. If I say the intersection of A and C in my example, I'm literally looking for the overlap. I'm looking for which elements are in both, and it's only little c. So it's going to be little c. Only the ones that are in both of them. So I think of this as the more elitist party. That not anyone's going to come to this party. Only if you are in both of these sets, then I'll open the door for you. Not just anyone that show up can come in. If I do, for example, C and D, intersection of C and D, let's look at it. What would that be? There is no overlap. There's nothing in common. Not zero. If you write zero, then I'm going to be unhappy. That is the empty set. Yes, there are 0 elements in the empty set, but the set is not a number. It's a different object, different thing, different concept.
You don't put the 0.
It's a phi. It's a Greek letter.
Oh, okay.
It's not a 0.
You don't put it in parentheses though?
No, you could. I'll accept it. It just looks a little weird with nothing in between the brackets. But you could, yeah. They introduced this, they reserved the symbol because in larger things with more sets, brackets with nothing in them, they get lost and it gets confusing, that's all. But no, I'll accept that for sure. Let's do intersection of A and B. Knowing that set B is a subset of A, if I'm looking at the overlap, there's just B and C. B and C. Whoa, that was not inverted bracket, I'm sorry. Which is the same as set B.
So you could just put equals B.
Yeah. So if one is a subset of the other, that subset is the overlap. And those are the only ones that's going to come to the party. If I say intersection of A and the universal set, what is the overlap between set A and the set of everything?
Just A.
It's going to be set A. Because A is automatically in everything. And the overlap is everything the first set brings. Intersection of A and the empty set. The overlap of a collection of things and nothing. It's nothing. There is no overlap. So if I look at these two, the union and the intersection, they are different. They're not the same. The union is the relaxed party. Come on, we'll open the door, you show up, doesn't matter. We are accepting all of them, no discrimination. The intersection says, no, not just anyone can come to this party. You better be in both or I'm not opening the door. In general, I won't know what elements are in the sets. So if I have two sets, let's call them E and F. I just have two sets. I don't have information about what's in them or anything. The Venn diagram then has to be set up in a way that I cover all the possibilities because I don't know what could happen. Yes, my rectangle, universal set, that's always the case. I can put a circle down for E, and without knowing exactly what the elements are, I can say the elements in E are inside the circle, the elements that are not in E are outside the circle. Don't know any specifics, but I can still visualize there are things inside E, there are things outside. The question might just not tell me. If I now look at another set, F, I have to position it in this way so that I can cover all possibilities. There could be elements that are not in any of the sets. Right? There has to be space outside for those elements. There could be an element over there that is in the E circle, but outside the F circle. There could be an element that's inside F, but not E. And there could be an element in both. So without knowing anything, I have to put them in this general position. Even if I do know something, let's suppose I know the intersection is, or the overlap rather, is nothing, it's empty, there is no overlap between them, I can still lay them out like this, and then later on we'll just put a 0 there to remind us that there's actually nothing in there. I can leave space for it, and some of these could just be empty. But without knowing that, I don't want to risk separating them when there could be an overlap with elements in it. So if I look at the, let's make it a color, let's make it blue. If I look at the intersection of E and F, and I want to color that in and tell and show which regions are covered by this new set that I'm making by way of an intersection. I can't consider things that are sitting over here because the intersection requires that an element be in E and in F. They have to be in both. And if an element sits over here, it's in E and not in F. So that's not a region that is included in the intersection. This side isn't either. It has to be in both. So it has to be this overlap. Is everyone happy with that, or happy with how to visualize the intersection of two sets? Which is why we can talk about it as the overlap, because of the Venn diagram. Because the intersection requires that any elements in this new blue region has to be in both E and F, and therefore the overlap. If I now just do another rectangle with two sets, where we can look at the union, I have my E circle. I don't know where it is. I put them in a general position. And let's go maybe pink. Let's go E union F and illustrate where that could be. The requirement for how to make that new pink set, or really a pink region inside that rectangle, the requirement is what? The union is the more relaxed one. It just says, no, if you're an E or an F, you are going to be pink now. You're in my new set. I don't care if it's an overlap or you're just in one, it's all good. So anything over here should be included because it's an E. Actually, all of E and all of F. I throw them all together. Overlap, just in one, just in the other one, you're all welcome. But not the outside, right? You have to be in one of those two sets to be included in the union. So I can visualize them and I can see the difference between the two and be reminded of their requirements and the difference between the two. Any questions on how to visualize the union and the intersection? How do we feel about that? Does it make sense? Anything that doesn't make sense? Feel free to ask. We have more than enough time. So, without knowing anything about two sets, that's the layout, and then I could combine them in different ways, union, intersection, and so on. But for many situations, and this is as far as we're going to go, I also want to look at three sets. We won't go further than that. Let's call them E, F, and G. Rectangle is over here. Rectangle. Always start with the rectangle containing everything. Well, my E circle could be over here. What's that little line doing there? There. Let's call that E. And I know if I include another set, I have to give it an overlap because I don't know anything specific about these sets, so I have to allow for a potential overlap. So that's the general position of two sets. Where should I put the third one to allow for all possible overlaps and combinations? Can you visualize where that G circle has to sit if I don't know anything? Yes, for sure. This is the only space I have, but I can't put it over here.
It has to include E
Right.
and F.
I have to put it in a way that it intersects them in all possible ways because I don't know anything else. I can't exclude any possibility. So that is going to be the general position of three sets. And it's something that I can always start with, even if down the line I get more information and realize that some of those overlaps end up with no elements, I can still start with this. And you'll see eventually we'll put numbers in, and some of those numbers could be zero. So there's no risk in starting with this general position. Now, in order to just practice this and really see if we understand Venn diagrams and regions and union and intersection, let's do exercise, I believe it's 5.2. Yes, on page 38. Exercise 5.2. Now, many people find this one a little confusing at first to understand what is being asked, and then once that is settled, understand how we are going to proceed through this. So if you have anything you're not sure about, please do not wait until the end. Say it right away. Shout something, throw something, do something. Because it's going to be difficult to backtrack once everything is colored and all kinds of things are happening. Don't think for a second it's just you. So, I have three sets. Any sets. Yes, they're called A, B, and C. They do not refer to our first example. Any sets A, B, and C. I could have called them anything. There are different ways to combine them to make new fancy sets. One way to combine them is to take an intersection as well as a union, and the brackets tell me which one to do first. So in this first way to make a new set that I don't know what it looks like is, remember BEDMAS says brackets come first. So the instructions there are do B union C first, then get a result, then combine it with A by way of an intersection. I can also combine three sets in this way. Do the intersection of A and B, then do the intersection of A and C, and then combine them with a union. And the question is asking for us to verify that the end result is actually the same. So first I have to understand the question. Not our answer, just the question. I can't go to an answer if I don't understand the question. That is something you're going to find in your potential teaching career. How often students of any level go to an answer or try and find an answer, but they don't really understand the question. They don't spend enough time on it, and then it's just a stab in the dark. You have no idea what you're doing if you don't understand the question. Do we understand the question? Any questions on the question? Not how we're going to do it, but I can't worry about that if I don't understand the question. I have different ways to combine three sets. A little more complicated, sure. I want to see if the end result on both of those sides are the same. So I'm going to do them one at a time. First one. The instructions tell me to combine the sets like this. Now I'm going to make my Venn diagram. Nice and big. I remember that's U. I will put my three sets in a general position because I know nothing more about them. Like so. I'll call them A, B, and C. Okay, so now I'm set up. Excuse me. All right. Now I'm going to use some color to help myself keep track of what I'm doing here. Otherwise, it's going to be really complicated. So, all the way until quiz 2, maybe some color. Color is going to help me with Venn diagrams. It just makes everything easier, nicer to look at. It's win-win. So now I'm going to make a plan here. I know the brackets come first. So let's make the brackets big. I'm just going to focus on the bracket portion first. I'm not going to do the whole thing at once. It's too much. I'm going to do it in sections. Just B union C. And I'm going to color that pink. But because that pink section is only concerning B with C, there is no A for the immediate future. A is not a part of my pink region. I don't look at it. I don't see an A. I don't see any of this. It doesn't exist. Because of the instructions telling me that B should go with C. So I have to sort of selectively not see A for a little bit. Just B and C. And I have to combine them with a union. What does the union require? Just everything. Throw all of them together. And in this case, what I should throw together is B and C. So all of B, all of C, there is no A, right? So those lines that A create, they're not even there. B with C, all of them together. It takes some practice, perhaps, to selectively see things as you need to and not be distracted by other things that are there, but for the immediate future don't play a role. It takes some practice. Is everyone happy with my pink result, which is not the final result, temporary result? So now, once I have the pink, I don't care about where it comes from. I figured it out. It's pink. I don't care where it comes from. See, I don't even see it. Totally forgot where it comes from. The thing that I have to combine the pink with, I'll make that blue. And that, in this case, is just A. So when I color something blue, there is nothing else. There is no B and C. It's the A circle, and that circle needs to be blue. For the blue section, there is no B and C. I don't see anything. I don't see pink, I see nothing. I color blue what I need to color blue. And then once that is done, I don't care where the blue comes from. I've done that already. It's just blue. Blue. So now the instructions say, to finish, combine the blue and the pink with an intersection. What does the intersection require? Yes.
The overlap of them.
It's the overlap of the blue and the pink. So my end result that I guess I'll make purple. The end result is the collection of regions that have both blue and pink in them. And therefore it is these guys. I won't highlight it so I can still see the blue and pink lines. I'll sort of outline it. Because of what the intersection requires. Both blue and pink. Is everyone happy, or does everyone agree with my end result being the purple regions? So because I did something fancier and it was a multi-step process, the region I get in the end is that sort of, I don't know what that is, 3-piece thing. Any questions on any of it? If I put that in the quiz, can you do that? All right, awesome. Oh, with practice, of course, not right now. Actually, pop quiz right now. So that was just half of it. You actually believe me? At least you cannot believe me.
We're just talking about bonus.
Oh,
Pop quiz bonus.
there's no need for a bonus if quiz 1 went well.
What if it didn't go very well?
Then there's a need for a bonus. Yes. I have some plans. I've put some feelers out. Some bonuses are gonna respond. Don't you worry. That was only half of it. That was only this half. There's another way to combine the sets, and I need to look at that and then see if the result I get from that method is the same as the purple. Okay, so this was half of it. But we got to draw stuff, it was fun. No, it wasn't fun? I enjoyed it. Their instructions, you can verify, are now like this. Brackets do come first. And now I have 2 of them. Okay, fine. But let me just set this up. Right, I'm not going to worry too much before I've set up my 3 sets. Universal set, a little A circle, a little B circle, a little C circle in general position. And I want to put them A, B, C in the same way as the top one. That would help a lot. All right. So I'm set up. Now I'm ready for systematically doing what they say I should do. There are 2 brackets. I might as well do the first one. But brackets do come first. Let's go blue. Let's make that blue. That requires that I combine A and B. So there is no C. You see this over here? See this line? No, it doesn't exist. There is no C. You have to literally look at this and not see the C, which is not the easiest thing ever. There's only A and B. There are only 2 circles. The intersection requires what? Overlap. And because there is no C, it is all of this. Now that I've done that, I don't care what was inside the bracket. People look at that detail for far too long. I've established that that's the blue region I get. I'm not going to rethink it. I'm going to move on. One danger is people do move on, but still look at the detail of that blue section. No, it's done. Is everyone happy with that? The next bracket, we will color maybe yellow. Not too bright, maybe like that. That concerns A with C. Do I see this B? Do I see blue?
No.
No, I see nothing. I see A, the A circle, I see the C circle. There is no blue, there is no B. I don't know what you're talking about. It's not there. That also requires an intersection, which is also the overlap, but now between A and C. So it's over here. Do this a little bit lighter so we can see that it was blue as well, like that. Something like that. And once I've done that, I don't care where it comes from anymore, it's gone. It's yellow. I only need to color. Now the instructions tell me to combine blue with yellow by way of a union. What does the union require that I do? Overlap? All of the colors are welcome. Maybe overlap, but not exclusively. Let's make it green. So as soon as there's a color, you're in, because the union doesn't discriminate. So I'll just outline it. If you have a color, you are in this new region. You are welcome. And then you see it is the exact same as the purple. Wasn't that fun? We drew some shapes, we colored some things. It's an improvement from the sequences and all the calculations, don't you think? I don't know. It's different. Yes.
Are you just showing us two separate ways to write the same thing?
The question is giving me two ways.
But what's up with like the equal sign?
Equal
you're
means
just-
the same.
Right. Okay. So it's just this is this too.
Yeah.
Okay.
The question is, can I verify it? Do I believe it just because they say it's equal? No, I verified that
Right.
it's the same
like,
result.
Is this true?
It is true, yes. Yes.
Is it still equal even though like most of the first one is shaded and then only the?
Only the end result matters.
Okay.
The path to get there doesn't matter.
Okay.
Yeah. That top line asks, is the end result the same in both cases? The colors, other than purple, completely irrelevant. That was just my option for figuring it out.
Yeah.
And someone else might not use that option at all. There are other ways to do this. But this is the nicest way for us. The least mathy way. Any other questions? No questions? First section had a lot of questions. But doesn't mean anything. So if you want to practice this kind of question with the Venn diagram, that is problem 5.1. 5.1. But if you look at problem 5.1, you see, okay, number one looks a little similar, not the same, similar, okay. So if I look at what I did here, I can practice that one, I should be okay. But the other ones have a little C somewhere in them. So maybe we should look at what that C means. There's one more way to make a new set. It's not a complicated way, but it is different from what we've had. So let us just mention that so that that problem can make more sense. One more way to make a new set, and it's called the complement. Make a general sentence here. The complement of a set, let's call it E, is the new set. and I will name it E with a little C at the top. And that set contains all the elements, and only those, that are not in E. So the set E is going to contain some stuff. Who knows what? The other things, the other elements that it doesn't contain, everything else we call the complement. Everything else. So if we now refer to our very first example over here, let's go this one, and we look at set A containing little a, b, and c, we can say that the complement of set A is everything else. So D, E, F, G, all the way to the end. It is everything else. But we don't say everything else, we say the complement. So the concept isn't as difficult, I think, as the union intersection one, because I take one set and a new set from that. It's not a combination in the same way.
Can we use the dash thing instead?
There are many ways to write it. You can use a little dash, you can use a line over top, whatever works for you. I won't be confused. Just make sure your dash is nice and clear. Yes?
It basically means like the opposite of.
It is the opposite, exactly. That is exactly what it means. Yes.
How do you know what elements are in A? Is it just meaning?
No, I have to know. For the complement, I kind of have to know. This one, for example. Though I could still visualize it, Venn diagram, with a Venn diagram. Even if I don't know exactly, it's going to be some circle, right? A. Could be this A in question, it could be something else. If I, for example, want to make, what color have we not used? Red. Oh, a little pinkish red. That's nice. A complement, I want to represent that. It is everything that A is not, meaning it's all the outside of A. Whoops, that went too far. Nothing can be outside the rectangle. It is everything else. Call it the opposite, which it is. Call it the complement, call it everything else, call it not A. Lots of options. Lots of options. But it's all the same thing. It's everything else. Everything else. So just as a side note, I'll do it over here. Note. What is the complement of the universal set?
Empty set.
The universal set has everything. The answer to this is everything else. There is nothing else. And the complement of the empty set has to be the universal set. Just to test our understanding of this complement concept. And now, like in problem 5.1, number 2 and 3, I can combine that with intersections and unions just to make it even more fun. As long as you go slow and systematically, carefully color in the pieces, it's totally fine. All right. So far we can do problems 5.1, 5.2, 5.3. 5.1 is the Venn diagram one. 5.2 and 3 are more concept questions. Do we understand what kind of elements we're looking at? Do we understand what restriction a set places on those elements, thereby selecting just some of them? And can we explain those things in words? There's just one note, I think, in 5.3 that I didn't specify. I see it now and I forgot to change it. The universal set is also called, as you cross over to statistics, which is really where probability lives. You know, statistics people.
Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Thank you.